Guys, assalamu alaikum. I hope you're all well and having a good day. So today we will solve a fluid mechanics question from the year October 2023. You all know it's a recent question paper. So the questions are really updated. So let's solve it. In the question they have said, a student carried out an experiment using a data logger. So she has been using a data logger in order to carry out the experiment to record the motion of a ball bearing. So they have been recording the motion of a ball bearing using a data logger as it fell through a liquid. So by reading this part of the question, we have already assumed that we have already guessed that this question is regarding fluid mechanics. The ball will be flowing, or the ball will fall through a liquid. Okay, so let's see what they have said. State the conditions under which Stokes' law applies to an object moving through a fluid. So we all know what Stokes' law is. When does Stokes' law is applied to an object? And the conditions that is required in order for the Stokes' law to be applied on an object or on an object moving through a fluid. So we all know, for an object, when it is moving through a fluid, let's see, here is all the fluids. If an object has to fall or flow or fail between the fluid, it has to be a spherical object. We all know that this is one of the conditions that needs to be made in order to Stokes' law to be applied. In order for this Stokes' law to be applied, the ball needs to be a spherical object, and the ball cannot fall or flow at a very high speed. It has to be within a low speed, or the speed cannot be a very high speed. And another thing is that the water flow around it cannot be turbulent flow. The flow needs to be a laminar flow, streamlined flow, which we say streamlined. The flow needs to be like this. The flow cannot be like turbulent. These are turbulent, and this is laminar. So these are the three things that needs to be maintained, or these are the three conditions that needs to be maintained in order for the Stokes' law to be applied when an object is falling through a liquid or a fluid. So let's go and write it down. The first thing that needs to be maintained is the object needs to be spherical. If the object is a square shaped or a triangular shaped thing, then Stokes' law will never ever be applied. So the object needs to be spherical. And another thing that needs to be maintained is the spherical object must fall at a low speed, not at a high speed. And another thing is that laminar flow. There should be laminar flow, or you can also write non-turbulent flow. Okay, so we are done with question number A. Let's move forward to the question number B. What they have said in the question number B. They have said the graph obtained by student is shown below. This is the graph, displacement time graph, and they have said us to explain the shape of the graph. So let's go and explain it. If we start explaining it, we can see that we all know displacement divided by time is equals to velocity. We all know velocity is equals to displacement by time. So this displacement time graph will give us the gradient of this displacement time graph will give us velocity. The gradient of the displacement time graph will give us this the velocity. So let's look at it. If we look at it more closely, we can see at the start of the graph the line is horizontal. The line here is horizontal, so the gradient will be 0 as well as the velocity will be 0. and after the straight line the graph is increasing, the gradient is increasing. Here the gradient is increasing, as well as the velocity will also increase. As the gradient is increasing, the velocity increases, and we all know when the velocity increases the drag force also increases. As the velocity increases, the drag force also increases. But somewhere at this point, you can see from this point to this point, the graph has suddenly become constant. So the gradient becomes constant, as well as the velocity becomes constant. This constant velocity is known as the V term, or the terminal velocity. The velocity has reached its terminal velocity. The velocity has reached its terminal velocity. So the thing that is going on here is, here the velocity was increasing, or the object was accelerating, and as the object was accelerating, the drag force was also increasing. But when the weight and the upthrust acting on an object becomes equal, because the upthrust force was increasing, and when the upthrust force and the weight force becomes equals, the resultant force on the object becomes zero, and the acceleration becomes zero. At that time the velocity becomes constant, or it reaches its terminal velocity, and the gradient is also constant at that point. But we have been asked here to find out about the shape of the graph, and we have been given the displacement and the time. So we can only relate this graph with velocity. We cannot mention about acceleration, because acceleration is not given in this graph. This graph is only about displacement, time, and velocity, because the gradient of the displacement time graph gives us our velocity. So let's go and write it down in our own words. The first thing that we are going to mention is this. The thing is, initially the gradient is 0. So the velocity is 0. So don't write your answer in this manner. I am writing it so that I can finish the video in a very short period of time and you guys don't feel boring. So this is the first part. We have to write 3 parts, and another part is this. We all know, as the velocity increases, as the gradient increases, the velocity increases. We have to mention it here. As the velocity increases, the gradient increases. And we have also mentioned this, the FD also increases with the increase of the velocity. The FD also increases, or you can also write it as drag force. Don't write it in such manner that the drag force increases. And another thing that we have to mention is this point, until the terminal velocity. The velocity increases and the gradient increases until this position where the gradient becomes constant and it reaches its terminal velocity. Until the gradient becomes 0 and the object reaches its terminal velocity. If the question wasn't about displacement, if the question wasn't about displacement time graph, then we could have also mentioned acceleration. If the question was about 6 marks or 5 marks question, then we would have also mentioned that as the velocity increases, the acceleration also increases and the resultant force also increases. There would have been another point in between these 2 points, and that point would have been that this point would have been as the velocity increases, the acceleration also increases, and in between these 2 points there would have been another point which would have said at one point when the weight and drag force become equal to the upthrust. When the weight and drag force becomes equal to the upthrust, the resultant force acting on the object becomes 0. The acceleration also becomes 0, and the object reaches a terminal velocity and the gradient becomes 0. This would have been the answer, but as they have only asked about the 3 marks, we have only written the main 3 points. We didn't write some explanations, some extra explanations. But no matter, but you never know, maybe in your exam day, maybe in October 2024 or in Jan 20 or in Jan 25, the question may arise, the similar question may arise but with 5 marks, but you have to write it in that way. So I have just said it for you guys betterment. So let's move forward and answer question number 18(2). 18(b)(2). Okay, they have said the ball bearing had a diameter of 1.6. The difference between the upthrust on the ball bearing and the weight of the ball bearing is this. This is the difference between the upthrust and the ball bearing. Okay, and another, so this is going to be our force. We all know force is equals to 6 pi r eta v for the Stokes law. This is the formula of the Stokes law, right? 6 pi r eta v. Calculate the viscosity of the liquid. So they have been asked us to find out this. So let's write it down. Force is equals to 6 pi r eta v, and they have asked us to find out this eta. So in order, we have got this force, we have the radius, we have to find out the radius using the diameter formula. The radius will be 1.6. as it is given in millimeter, we have to convert it in meter, into 10 to the power minus 3 divided by 2. This diameter is divided by 2 to find out the radius, which will be 8 into 10 to the power minus 4 meter. So we are done with finding the radius as well. Now we have to find out the velocity. We all know that at this point it reaches its terminal velocity. At this point it reached its terminal velocity. So let's go and find out the terminal velocity to be able to use it here. So this was the position where it reached its terminal velocity. We have to find out this terminal velocity using the gradient. We have to find out the gradient. We all know the gradient is found out by change in y-axis divided by change in x-axis. So here this position is, if this is 10 and this is 20, this is going to be our 15. So this point is taking us 0.5, as there are 10 points in between. 10 points, 5 centimeter. So every point is 0.5 centimeter. So this is our 10.5, this is our 11, and this is our 11.5. So this position is 11.5 centimeters. And from here it is going to be, this is 1.2, and this is 1.1, and this is 1.2. So for 1 seconds it is 5 points. So every point is going to be 0.2. So if this is 1.1, this is 1.2, this is 1.4, and this is this is between 1.4 and 1.6. So it is going to be 1.15. So let's write it down. 1.15 minus 0.6 is this position. 1.15 minus 0.6. So let's write it down as 11.5 divided by 1.15 minus 1.15 minus 0.6, which is going to be as 20.9. And we all know the velocity needs to be in meter per second, but this is in centimeter. So we have to divide it by 100, which will be 0.209. So this is how we have find out the terminal velocity using the gradient. So let's go and write it down in the next page. So here the velocity, the terminal velocity will be 0.209, which we have recently find out. So now we can use it. If we can use it, we can find that viscosity means the N using F divided by 6 pi r V. So our force was 1.45 into 10 to the power minus 4 divided by 6 into pi into this radius 8 into 10 to the power minus 4 into this velocity 0.209. So the answer will be 0.0460 pascals per second. So this is our answer, 0.0460. This is our answer. Okay, so we are done with finding the B number question. Then let's move forward to the question number 3. In the question number 3, they have said the student heated the liquid and repeated the experiment. Okay, so they have repeated the experiment using the liquid. So the thing is, this is the water level or the liquid level, and a ball was flowing through it. What they have done is they have increased the temperature. They have increased the temperature of the liquid. The temperature of the liquid has been increased. So we all know, as the temperature increases, the viscosity also increases. And as the viscosity increases, we all know, since the temperature as the temperature increases, the viscosity decreases. As the temperature increases, the viscosity decreases. Therefore, the drag force on the object also decreases. As the drag force increases, it will have a higher resultant force. As the opposing force decreases, the thrust force increases, or the forward force increases. As there is a higher resultant force, a larger acceleration, there is a larger acceleration. As the resultant force increases, we all know F is equals to ma. When the force increases, there is a greater acceleration, and therefore a greater velocity, and the velocity also is greater. So let's go and write it down in our own words. They have given us 4 marks, so we have to write it accordingly. They have given only 4 marks, so let's write it down. We have write that at the temperature increases, the velocity decreases. At higher temperature, the viscosity will be less. According to, this is our point number 2 and this is our point number 1. We have to write 4 points for 4 marks. F is equals to 6 pi r eta v. Okay, this radius is constant, right? No matter what the temperature of the liquid is, the radius is not going to change. The ball is not going to get bigger, or the ball is not going to get smaller. We have to mention it as well. The size of the radius, the size of the ball is constant. We cannot write the size, we can write the radius is constant. So we are done with point number 2. So let's write point number 3. So the drag force is also smaller. We have to write this point. The Fd is less at a given speed. We have to mention this. And as the ball is not regarding resultant force, we cannot write the resultant force part, but the resultant force part is a fact, it's true. We have to just mention the velocity part, as we have been given only 4 marks. If the question was about 6 marks, then we would have also mentioned these 2 parts. As the question is only 4 marks, and we have to mention using this formula, as the force is not given in this velocity, in this formula the resultant force is not given, so we have to mention the velocity. The velocity is greater, the terminal velocity will be greater. As resultant force will increase, the acceleration will also increase. In return, the velocity will be greater. So we have to mention it that the terminal velocity is greater. As the velocity is greater, we all know speed is equals to distance divided by time. As the velocity increases, the time decreases. So as the velocity is greater, the ball will take lesser time to fall. The ball will take less time to fall. So we are done with this question. They have said the ball bearing took less time to fall at a given distance when the liquid is at a higher temperature. Assume the density of the liquid is constant. So we have just mentioned about the time as well, because they have asked us to mention about, or they have asked us to talk about the time as well. Otherwise we would have never mentioned this time part. We would have only mentioned this force and acceleration part. But as they haven't asked about the force and acceleration part, they have asked about the time. So time is only referred using this velocity. So we have mentioned the velocity part rather than this resultant force and acceleration. So we are done with question number 18 of the recent concluded paper, October 2023, fluid mechanics. So have a good day, guys.